Okay, let's dive right into this explainer because we are looking at a truly monumental shift happening in global agriculture right now. Today we're going to focus specifically on India. We're looking at rapidly expanding smart cities, places like Pune, Chennai, and Ahmedabad, and how they are transitioning away from traditional soil-based agriculture straight into high-density vertical farming. And you know, this isn't just some sci-fi futuristic concept anymore. It's a pressing necessity, and it's being backed up by some seriously cutting-edge engineering and really robust economics.
So the whole crux of this transition is captured perfectly by this quote from Kalantari and colleagues. We live vertically, so why can't we farm vertically? It's just a beautifully simple question, right? But it totally challenges us to fundamentally rethink how we use space to feed our densely populated cities.
Here is our quick roadmap for today. 1. The urban farming imperative. 2. Engineering the soilless stack. 3. The IoT greenhouse brain. 4. Machine learning nutrient precision. And 5. Architectural and economic triumphs. Let's jump in.
Section 1. The urban farming imperative. Let's start by zooming out for a second and looking at the overarching problem that is actually driving this transition.
The numbers here tell a pretty daunting story. India currently has a population of 1.27 billion, and that is projected to grow by 25% by the year 2036. At the exact same time, arable land is shrinking. We're dealing with severe land degradation, desertification, and of course, rapid urbanization. So the traditional horizontal farming model, it's simply becoming unsustainable. We're literally running out of ground space, and climate change is severely stressing our water resources. So what's the solution? Well, we have to build upwards.
Section 2. Engineering the soilless stack. Let's zoom in a bit and look at the actual chassis of this vertical farming hardware, the systems that are completely replacing traditional soil.
The foundation of this entire revolution relies on controlled environment agriculture. The most common approach you'll come across is hydroponics. Basically, this is a soil-free farming method. It uses a water-based nutrient solution, and instead of soil, the plants are supported by inert mediums. Think things like clay pellets or perlite. This method is amazing because it drastically conserves water, it totally eliminates soil-borne diseases, and it significantly boosts crop yields.
Think of it like a giant, highly efficient plumbing puzzle. A grow tray holds the plants up top, while a reservoir sits down below. A simple automated timer and air pump system just continuously circulates this vital, nutrient-rich water directly right to the root zone. Once the plants absorb what they need, the water cycles back down to be reused. It's incredibly efficient, and it forms the backbone of most vertical indoor setups today.
Now, moving to an even more advanced chassis, we have Aeroponics. This takes the whole concept a step further by entirely removing the growing medium. Instead, the plant roots are literally suspended directly in the air, and they're periodically misted with a highly calibrated nutrient solution. Notice how the roots just hang freely in the open-air chamber. This allows misters at the bottom to precisely control the humidity and the nutrient delivery. Because the roots have 100% access to oxygen in the air, aeroponics offers superior oxygenation, and that leads to incredibly fast plant development and uses even less water than hydroponics. It's really cool.
Finally, for our third major engineering stack, we have aquaponics. This is a fascinating system because it combines fish farming, or aquaculture, with soilless vegetable production in a continuous, recirculating loop. It creates a completely symbiotic ecosystem.
What's really interesting here is the biological magic happening right in the middle. So the fish produce waste that is rich in ammonia. That wastewater flows into the grow bed, where naturally occurring nitrifying bacteria break down the toxic ammonia into nitrates and then into nitrates. Now, these nitrates are the absolute perfect fertilizer for the plants. As the plants soak up the food, they filter and clean the water, which is then sent right back to the fish tank. It is a brilliant closed-loop masterpiece. Section 3. The IoT greenhouse brain. We've got our hardware, but how do we actually control it?
Operating a vertical farm manually is pretty much impossible at scale. It requires some gritty hardware and a really logical workflow. Right at the center is an Arduino Mega microcontroller. This basically acts as the brain of the whole operation. It connects to sensors that are constantly reading pH, temperature, and humidity. It's a massive upgrade from the older wired systems which, let's be honest, were incredibly difficult to install and maintain across a sprawling facility. And this step-by-step data flow is what makes wireless agriculture possible. First, sensors gather the environmental data and feed it to the Arduino brain.
Then, a tiny Wi-Fi module called the ESP8266 transmits this data directly up to a cloud database, like ThingSpeak. This is a real game changer because it allows farmers to remotely monitor and adjust their greenhouse environment from a smartphone, literally anywhere in the world, perfectly automating the lighting, the temperature, and the water pumps.
Section 4, Machine Learning Nutrient Precision. Now we're going to zoom in to the absolute atomic level to explore a critical software update that actually saves these crops from devastating nutrient burn. So closed systems recycle water, which is absolutely great for conservation, but it creates a massive micro-challenge. You see, plants absorb different ions at different rates. To monitor this, farms use ion-selective electrodes, or ISEs, to measure specific nutrients. But there's a fatal flaw here. In really dense nutrient solutions, these sensors suffer from ion interference. They basically get confused by competing ions and start reporting faulty data. That can lead to a toxic buildup of salts and literally the sudden death of an entire crop.
Actually, let's not get bogged down in the complex chemistry for a second. Just look at the difference here. Researchers have applied a lightweight machine learning quadratic model to fix this sensor artifact. By processing that faulty data through this model, our sensor accuracy for vital nutrients like calcium, nitrate, and ammonium just skyrockets. We go from a pretty dangerous 59% accuracy all the way up to a highly precise 98%. This machine learning layer ensures the nutrient solution remains perfectly balanced, which practically guarantees the crop's survival.
Section 5. Architectural and Economic Triumphs. Finally, let's zoom back out to the macro level and see how this technology physically integrates into our cities and our economies.
The architectural proposals here are just staggering. Take this proposed 13-story, or ground plus 11, vertical farm structure. You have a ground floor for rainwater harvesting, the first floor is set up for food processing, and multiple mid-level floors are dedicated strictly to high-density farming. Floor 7 is the environmental control hub, and floor 11 holds the massive water tanks. Research indicates that a skyscraper scaled to 30 floors could produce the equivalent of 2,400 acres of traditional horizontal farmland. It is a breathtaking optimization of urban real estate.
And guys, this isn't just academic theory, it is happening right now across India. Startups like Urban Kisan, operating in Hyderabad and Bengaluru, are yielding 30 times more produce than traditional farming, all while using 95% less water. Down in Goa, Letcetera Agritech is pioneering pesticide-free indoor hydroponic lettuce. Meanwhile, UGF Farms in Mumbai is actively converting barren urban lots and empty spaces between buildings into zero-carbon footprint microfarms. The economics are proving to be just as resilient as the engineering.
Which brings us to our final thought. As we face the mounting challenges of population growth and climate change, the solutions are already being built. Look out your window right now. Which abandoned warehouse, vacant lot, or towering skyscraper in your city is going to be transformed into the next local farm? How soon will the skyline of your city become its primary source of fresh, sustainable food? That is the exciting reality of vertical farming. Thank you so much for joining me on this explainer, and definitely keep your eyes on the skyline.